Okay guys, welcome to part 2 of the video for obtuse angles and exact values. So in this part we're going to take a look at the exact values for sine, cos and tan theta for certain values of theta. So we can do this using two special triangles, and the good thing about this is that you don't have to memorize these as long as you understand the triangles and how to draw them. So the first triangle we're going to start with is an equilateral triangle that has a side length of 2. Okay, and we know with an equilateral triangle that all of the angles also have to be 60 degrees. Now, to use trigonometry, for now I need a right angle triangle. So if I drop a perpendicular bisector there, that means I've cut this equilateral triangle in half. Okay, but I've got a right angle here now. So that means that the length of this side, if I'm just looking at this half of the triangle, is now 1. Okay, this angle here is 60 degrees. And this angle here is half of 60, so 30 degrees. And I can work out the value of this side using Pythagoras theorem. So 2 squared minus 1 squared is 3. So that side would be the square root of 3. Okay, I'm just going to erase this 2 here so that it doesn't clutter our page. Right, now we're going to take a look at, first of all, we'll look at 30 degrees. So if I wanted to calculate the sine of 30 degrees, well, that's just going to be the opposite, which is 1 over the hypotenuse, which is 2. So the sine of 30 degrees is a half. Okay, if I wanted to calculate the cos of 30 degrees, well, that's going to be the adjacent side, which is root 3 over the hypotenuse, which is 2. So root 3 over 2. And the tan of 30 degrees is opposite over adjacent. So opposite is 1, adjacent is root 3, so 1 over root 3. And we often rationalize the denominator here. So you'll often see this written as root 3 over 3. Okay, so this is what we mean by exact values. We're not actually working out what root 3 over 3 is as a decimal, we're just leaving it as a surd. Okay, and this is the kind of thing that you'd be expected to know for your non-calculator paper because you can do this without a calculator. All right, we can do the same thing for 60 degrees. Okay, so looking at the same thing for 60 degrees, we've got that the sine of 60, so now this angle here is opposite over hypotenuse, so root 3 over 2. The cos of 60 is equal to the adjacent over the hypotenuse, so 1 over 2 or a half. And the tan of 60 degrees is equal to the opposite, root 3, over the adjacent, 1, or just root 3. Okay, so the second triangle that we can use is an isosceles triangle. So that means that this angle and this angle are equal. They're both 45 degrees and it's a right triangle. And that means also that that length is the same as that length. So what we're going to do is we're going to say, okay, if this is length 1, that's length 1, then that means that the hypotenuse has to be 1 squared plus 1 squared, and then the square root of that, so root 2. And from here, we can get the exact values for sine, cos, and tan of 45 degrees. So the sine of 45 degrees, and it doesn't matter which of those 45 degrees you use, so we'll use this one down here, is the opposite over the hypotenuse, or 1 over root 2. Again, rationalizing that, we would often see that as root 2 over 2. The cos of 45 degrees is the adjacent over the hypotenuse, so again, 1 over root 2, or root 2 over 2. And the tan of 45 degrees is going to be opposite over adjacent, or just 1 over 1, which is 1. Okay, so these are the ratios that you'd be expected to know. In addition, looking at this table here, so we've got the 30, 45 degrees, and 60 degrees as noticed. I've also given you the values for 0 degrees, and you can find that out using the unit circle. But sine of 0 degrees is 0, the cos of 0 degrees is 1, and the tan of 0 degrees is 0. Okay, the sine of 90 degrees is 1. The cos of 90 degrees is 0, and tan of 90 degrees is undefined because remember tan is sine divided by cos. Well, that would be 1 divided by 0, which you can't do. You can't divide by 0, so tan of 90 degrees doesn't exist. There is no value for that. Okay, so we're going to use what we did with the obtuse angles here, combined with our knowledge of these special angles to work out the exact values of the following. So the first one here is pretty easy because we've got an acute angle. Sine of 60 degrees, we can just read off the chart, is root 3 over 2. Now the cos of 150 degrees, we've got to relate that to its acute supplementary angle. And remember, because obtuse angles of cosine are negative, we're going to say that that's equal to the negative cos of 180 degrees minus 150 degrees, or the negative cos of 30 degrees. So from our table, we can see that cos of 30 degrees is root 3 over 2. So that means that the cos of 150 degrees is negative root 3 over 2. Okay, tan of 135 degrees. Again, tan is negative in that second quadrant. So to work out the tan of 135 degrees, we need to look at the negative tan of 45 degrees. So tan of 45 degrees is 1. So that means the tan of 135 degrees is negative 1. Okay, so you can go ahead now and try the rest of the exercises from chapter 4F.